Today we're talking about quadratic properties. We're still in the functions unit, and we're going to finish that out. We're going to cover quadratics, exponentials, logarithms, sinusoidal functions, all the functions, okay? So today you're going to be learning how to use quadratic equations to draw different conclusions about their properties in all things quadratic. The next day we're going to do quadratic models, and then we'll move forward after that. So, quadratic function. You're going to take a few notes yourself. Okay, you're going to take a few notes yourself. Remember, you're taking smart notes. Okay, so this might have to be on the actual lines. But a quadratic function is in the form of f of x equals ax squared plus bx plus c, where a, b, and c are, what is that? Real numbers. Okay, and a does not equal 0. Now, if you think about this, if a equals 0, what's 0x squared? What is that? What does that become?
0.
It just becomes 0. So technically, this would be bx plus c. This right here is not a quadratic, okay? So a can be any other number, but it cannot be the 0. Otherwise, you'll have a, what kind of function? What is that?
Linear.
A linear function, okay? You'll have a linear function. So all quadratics will have a squared term in it, okay? It will have a squared term. That's how you know you're dealing with a quadratic, okay? And then, of course, you'll have...
Any students who have not received...
So, let's go through this. Now, all this should be review, hence the blanks in all these different areas, okay? You guys have been dealing with quadratics ever since Algebra 1, okay? So when I say you're taking smart notes, you guys should have remembered a lot of this stuff about quadratics, okay? The most simplest basic parent function for a quadratic is what? Don't overthink it. What is the most simplest quadratic function you know? Find yourself. That is the general form. Like the most, like when you were dealing with quadratics, what was the function that you dealt with?
F of x equals y?
No. Because remember, f of x is y. It's the same thing as saying y equals. Y equals what? How did you know that if you were given a function, you knew that it was a quadratic? That it looked like that?
X to the power of 2.
Thank you, Christian, for saving this sinking ship. Yes. X squared. That is your most basic function. Okay? That was your parent function from Algebra 2. That was your parent function from Algebra 1. Okay? That was your most basic, okay? The graph was called a what? What was that shape called?
Parabola.
It was a parabola, okay? It looked just like that, what you see over there in the right, okay? It had an axis of symmetry. Who remembers what the axis of symmetry is?
It's the line in the middle.
It's that dotted line that goes straight through the middle. Now, the middle of the quadratic, you have this point right here. Not the apex, it's called the vertex. Okay, it is called the vertex. It's also known as a turning point. Okay, where the graph goes from decreasing to increasing or increasing to decreasing, that's called a turning point or a vertex. In this particular case, on a quadratic. Okay? In this particular case that we see here, for your most simplest quadratic function of x squared, its minimum point was at 0, 0. This is the minimum. It is the lowest point that's on the graph. Any other point that's on the graph is not, there's another point that's lower than it, except for this one right here, except for the vertex. Okay? Now for the most simplest quadratic function, which is what again? X to the power of 2, x squared. The range of this function would be what?
All real numbers?
Not all real numbers. Range related to what?
Oh, the y value.
The y values, okay? So what's the, and range was the...
So all numbers greater than 0?
All numbers greater than 0. Did it equal 0?
No.
Yes, because of that point right there. What's that point called? The vertex. So it's everything greater than or equal to 0. How do I represent that?
Y such that y is greater than or equal to 0.
And what am I missing here?
The
Which kind?
The one with the little triangle.
Who remembers the name of those?
Set builder.
Well, it's called set builder.
Set of.
The set of, yes. So the set of y values such that y is greater than 0. How would I write that in interval notation?
Bracket.
Yeah, bracket.
Which one is it? Bracket or parenthesis?
Bracket.
Bracket.
0,
0.
comma, infinity. Parentheses.
Here we go. Okay? What is the domain of any quadratic function? It's all real numbers, okay? Because those arrows indicate that it keeps on going forever and ever. It's going to get bigger and bigger, okay? Plus, x squared doesn't have a variable in the denominator or a square root or anything that's going to prevent it from not being defined anywhere, okay? So, let's look at the different forms that a quadratic can be written in. The first one is the general form. This one's in your foldable, okay? When a is greater than 0, and I'm talking about the number that's attached to the x squared, then that tells you that the graph is going to open up, meaning it's going to look like this. But if a is less than 0, that means the graph is going to open down, okay? Now, it doesn't matter whether it's a 1/2 or a -12. It's whether it's going to be a positive or a negative, okay? Whether it's going to be a positive or a negative. The curve intersects the y-axis at 0c. Okay, so whatever that c is, whatever the constant is in the general form, that is the point where it intersects the y-axis. To find your axis of symmetry, again, that is the line that goes straight through the vertex of the parabola. It's found by doing the formula x equals -b over 2a. X equals -b over 2a. So whatever that value is attached to the x. Whatever value is attached to the x squared, you just plug it into the formula. Now, the one thing you do need to be aware of with the axis of symmetry is that it is an equation. It is an equation, which means you need to have the x equals and then the value. Without it, it's incorrect. Okay, you need to have the x equals because it is an equation. But one benefit is about when you find the axis of symmetry is that you're also finding the x-coordinate of the vertex. Okay? So the x-coordinate of the vertex is the axis of symmetry. Reason why is, again, that line is going straight through the vertex. And when you look at a parabola on an actual Cartesian plane, an xy plane, that axis of symmetry is going through the x-axis. So then, of course, whatever that value is, that is the x-coordinate of your vertex. Your x-intercepts, also known as your roots or your solutions, can be found by using factoring or graphing when y is equal to 0. Okay? So you need that old skill of factoring. Have we reviewed factoring in this class? How you factor a quadratic?
We did in the beginning.
I feel like, that's a prior knowledge type thing. Okay, that's a prior knowledge type thing. So if you're given a quadratic such as x squared minus 4x plus 3, and I ask you to factor this, you can do the x. What number goes on top?
3.
The constant, the c. What number goes on the bottom? The -4, the value of b. And then you ask yourself,
What can you multiply to get 3 and add to get -4?
multiply to get 3, add to get -4. What are those numbers? Okay, so this factored would be x minus 1 and x minus 3. To find the actual x-intercepts, that can be found by using factoring when y is equal to 0. Considering this would have been f of x equals this function, then you would set this equal to 0, and then you set both factors equal to 0. Okay? The factorized form. As you can see, that's f of x equals a, x minus p, x minus q. This a is the exact same a from before. That's why it says the same rules apply with your a. Okay? So if a is greater than 0, what does that mean? It opens up, and if a is less than 0, It opens down. So that's what I mean. The same rules apply with A in the factorized form as it does in the general form. Now, it intersects the x-axis at P and Q. That's why it's called the factor form. It's also known as the x-intercept form, because you're basically given your x-intercepts in that particular form. Okay? Your axis of symmetry. You take your x-intercepts, the P and the Q, you add them and then divide by 2. The reason why is because in a quadratic that is in an xy plane, okay? Because the axis of symmetry splits that quadratic down the middle, it makes it symmetric. So whatever the x-intercepts are, the axis of symmetry is that point that's halfway between them. It is that point that's halfway in between them. So if this x-intercept is -1 and this x-intercept is 3, to find your axis of symmetry, you would add them together and then divide by 2. What's -1 plus 3?
2.
Divided by 2.
1.
So x equals 1 would be your axis of symmetry. Okay?
So your axis of symmetry is like an imaginary cow line.
It is.
In the middle of the parabola.
Correct.
Okay.
And it splits it in half equally.
Okay.
Okay? That's why you're able to add your x-intercepts and then divide by 2 to get your axis of symmetry.
Now, it would be the same thing if the parabola was horizontal, like going this.
Yes, but
You
the
would just use
rules
your line.
apply. Yeah, you'll use the y-intercepts in that case.
Yeah.
Now, one benefit is you do not have to worry about parabolas that open left and right in this class.
Okay.
Only yours that open up or down.
Okay.
And again, because the axis of symmetry goes through the x-coordinate of the vertex, that's the same way you find it. Okay? Questions on factor form? Last one is vertex form. F of x equals a parenthesis x minus p squared plus q. It's called vertex form because in this form you are given the vertex. The vertex is PQ. The axis of symmetry is the x-coordinate of the vertex, so it's nothing but x equals p. Okay, nothing but x equals p. The same rules apply for A that they would for any of the other forms, and yeah, that's pretty much it. Okay? Now, the one thing you have to be careful of with vertex form as well as with factor form is this right here. Okay? It's x minus p, which means, remember we were doing with transformations? Think back, at the very beginning of the functions unit. When we were dealing with transformations, anything that was on the inside,
It's opposite.
it was the opposite, right? So if you had x minus 3, that actually meant you went 3 to which direction?
Right.
You went it to the right, which means is that if you're given a quadratic that's in vector form like this one right here, your vertex, what's the value of p? Is it -3 or +3?
Positive.
It's +3. The reason being, again, it's x minus p. What value did you plug in for p? So then that way it stays in x minus p. You see what I'm saying?
Yeah.
Okay? So your vertex will be 3 comma what? 2. To finish it off. Question?
Where do we write this one? Because I'm kind of confused. You said that's vertex form?
That same concept applies back here with this factorized form, okay? With this factorized form, if you're given y equals x plus 2 and x minus 1, what are your x-intercepts?
-2 and 1.
-2 and +1. It's the opposite. So you got to be careful with those two forms there. And because they're points, there would be -2, comma 0, and 1, comma 0. There you go. Okay. Questions on these forms? Okay. All right. So we're going to look at this one here. We're going to look at this one together just to make sure you guys kind of understand some properties, and then we're going to look at some IB examples, and those you'll actually have hard copies of. So you have a function, x squared plus 6x plus 8. It is a quadratic function. What form is it in? Which of the three forms is it in?
General.
It's in general form. So if you need that assistance, go ahead and look at general form. And then you see, okay, it's asking you to find the point where the graph intersects the y-axis. Looking at what we have for general form, the graph is going to intersect the y-axis at 0C. What is C in this problem?
8.
It is 8. So the point where the graph intersects the y-axis is the point 0, 8. Okay? The general form gives you your y-intercept very nicely, very easily, as long as you are able to identify what the constant is. Question so far? The equation for the axis of symmetry. What's the formula for the axis of symmetry? Missing something.
X equals negative b over 2a.
You gotta have that x equals, hence the equation. In IB, they will bold this to remind you it should be an equation. Okay? What is b in this problem? So it's going to be a negative 6 all over 2 times a. What's a in this problem?
1.
What's 2 times 1?
2.
What's negative 6 divided by 2?
Negative 3.
So x equals negative 3 is your axis of symmetry. So far, so
So do we have to do all that if it just says the equation of axis of symmetry? Or can we just write the equation and still get it right?
like you actually need to give the number. Like you don't have to show all the steps I did, as long as you get that part. You're good. Okay. Now the coordinates of the vertex. Now because the axis of symmetry gives us our what?
Like, what do you mean?
Oh, okay. So we got this. Okay, so we draw like midpoint, not midpoint.
The vertex?
It gives us what part of the vertex?
X.
The x. Since we already know that the x coordinate of the vertex is negative 3, how do you find the y coordinate?
Like negative 3 for x.
Where?
In the original. For
In-
x squared.
Into the original. That x squared plus 6x plus 8. What is that?
9
9 minus 18 plus 8. Negative 1.
negative 1.
So your vertex is negative 3, negative 1. So that's so good?
Mhm.
Now, it asks to find the coordinates of the point or points of intersection with the x-axis. In other words, it's asking to find what? What's an easier way to say that?
P and Q.
Basically, your P and Q, your, not your vertex,
X values.
Roots?
your roots, your x-intercepts. Find the coordinates of the points of intersection with the x-axis, aka x-intercepts. Okay? How do I find my x-intercepts?
You have y equals 0.
Y equals 0, okay? What do I need to do to this?
Plug in your factor.
I need to factor. You factor to find your x-intercepts, to find your roots, to find your solutions. What two numbers multiply?
To get 8.
To get 8.
And then add to get 6.
Add to get 6. 4 and 2, both positive? So that's x plus 2, x plus 4. And consequently, you actually have written it in factored form when you do this. Okay? What are my x-intercepts?
Negative 2 and
Negative
negative 4.
2, negative 4. You mean negative 2?
Comma
Negative 2
0,
equals 0.
negative 4, comma 0.
Questions? General form is usually the one where you have to do the most math to find all of this. Okay? Vertex form, pretty straightforward. Same thing with factored form. You can get all the other ones with not as much work needed. To sketch it, of course, if you have your x-intercepts, you go ahead and graph those. So negative 4, negative 2. You have a vertex at negative 3, negative 1. You know your axis of symmetry cuts straight down the middle of it. and you represent your axis of symmetry with a dotted vertical line, and this graph opens up because A is
Positive.
positive. Questions? Alright, let's look at this. The intersection between two functions. In this case, we have the intersection between two quadratics. Now, when you're looking at the intersection between two curves, algebraically, what does that mean?
They're equal to each other?
They're equal to each other. If two functions intersect each other, that means you're trying to find that point where the x values are the exact same. How do you do that? You can do that by setting the functions equal to each other. So, in this particular case, you have two quadratics. Okay? And you're trying to find that point of intersection, so you need to set them equal to each other. So that's x squared plus x minus 4 is equal to 3 minus 4x minus x squared.
Do you need to rewrite g of x before you set them equal to each other?
You don't have to.
Okay.
Because from here, we're gonna solve this. Okay? In order to solve this, to solve any quadratic, factoring or graphing. Okay? Or quadratic formula if you remember it. Or completing the square if you remember. But in order to do that, this basically needs to equal 0. How do I get this to equal 0? How do I do that? I got an equal sign here though. So I can't combine. Combine is usually when everything's on the same side, but they're on different sides. How do I do that?
You can cancel out the x squared. One's positive, one's negative.
But they're on opposite sides of the equal sign. It's a difference. When they're on opposite sides of the equal sign,
Oh, then you can add it over.
yes, I can add it over. Because if I add x squared over, there'll be no x squared over here, correct? What do I need to do for this one?
Add it over.
I need to add over 4x. And this.
Subtract it.
Because when I do that on the right side, it will equal 0. And on the left side, you'll have this. Now, we're doing this one by hand because we need to review how to factor my simplest quadratic function. Students?
So you have to multiply 2 times 7 before you factor it?
You have to multiply 2 times, not positive 7, but negative 7. What is that? That number went on the top. What went on the bottom? 5. And you still had to ask yourself what two numbers,
Multiplying it negative 14 and adding it 5.
which were?
7 negative 2.
7 and negative 2. Now from here, this is where it varies depending on who taught you how to do this. I know how I taught Michaela and Isabel because I had them last year, but I have no idea how anybody else taught you guys.
To divide the 7 and the negative 2 by 2.
Okay. Slide divide bottoms up? Okay. If you're like, I don't know what that is, this is just one of the ways to do this. Because once you got your factors, because you multiply by 2 at the very beginning, you have to divide by 2 at the end. Okay?
Can you do that before you set them equal to 0?
And you do that before you set that equal to 0. Okay? And so,
So then it would be 2x plus 7. And the other one would be x minus 2.
because technically, we're reviewing factoring. That's how you would do it. And then from here, you would set both of these equal to 0. So that'd be 2x plus 7 equals 0. How do I solve for x?
Minus 7.
Minus 7.
Divide by 2.
Divide by 2. So x equals a negative 7 over 2, or a negative 3.5. X minus 1 is equal to 0. So x equals 1. Questions on how you factor when a is not 1?
You split? 7 divided by 2, and then you put 7 in the bottom.
Because anytime anytime this number doesn't reduce, you always bring the bottom up when you're factoring.
Oh.
Yes.
With the end result, it would still be if you were to just divide 2 from 7 rather than doing bottoms up, you'd still get x equals.
Sure, but we did this way to review factoring. 1, because if it asked you to factor this, what you see here in this line would not be acceptable. You would need to go to this line. But for solving purposes, yes, you could do it from there. Now, if it asks you to find the solutions when the two are equal to each other, that would be your answer. But it asks you to find the what? Their intersection points. The points, which means you need a what? If you need a point. You need an x and a y value. So these two quadratics intersect at 2 points. Okay? The first one is at -7/2 in some value, and the other one is at 1 in some value. How do I find that y value?
Plug that number into
Plug it into
each original, like, F and G.
Either one. You don't have to plug it into both because since it's the same value on both graphs, you pick whichever one you want to plug it into. Okay? So right now, I want you guys to plug in -7/2 into either F or G. Pick one, and then plug in 1 as well to get my y value. What's the y value?
For -3.5 is -19.75.
19.75? -19.75?
Yeah.
I put 19/4
19/4? Wait, 19/4?
for the fraction.
That's what I got.
Yeah, I got that too.
19/4? -19/4.
No.
I didn't get negative.
Positive.
I got negative.
Ooh, okay. Got some different things. What? It would be a positive 19/4. Be very careful. Make sure you have parentheses around that -7/2 because without it, it's going to square 7/2 and then make that number negative. So make sure you put parentheses there. What you get for 1?
Negative
2.
-2.
Very good. Okay? That is algebraically how you would do it. Again, we did it algebraically so I can refresh your memory on how to factor. Another way you can do it always is you can use your calculator. Go to your y equals. Everyone should be doing this. We're going to plug f of x into y1, g of x into y2. So that's x squared plus x minus 4 into y1. We're going to plug g into y2. And then we're going to graph. Now, again, I don't even remember the last thing I did on this calculator. How do I go back to a standard window?
Zoom 6.
Zoom 6. Very good. So we should see 2 quadratics. There's the first one. There's f of x. And there's g of x. Okay? And remember, anytime you're looking for where they intersect, you're basically looking for those points right there and there. Who remembers how to do this?
Second trace.
Second trace.
5.
Option 5. And because there's 2 intersection points, whichever one I'm looking for first, I move my cursor closer to that intersection point. And once I get there, it removes. What do I do? Enter, 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 and there is 1 -2. Y'all remember this? Okay, I know y'all been going on break, so I just want to make sure y'all haven't forgotten anything. Okay, you would do the exact same process, second trace, option 5, and then you move the cursor closer to the other intersection point to get that one. Yes? You haven't forgotten? Okay. All right. Okay, let's take a look at the next one. Here's an IB one. You should recognize it's an IB problem. Okay? How it's set up. The graph of the quadratic 3 plus 4x minus x squared intersects the y-axis at point A and has a vertex at point B. Before we start looking at the questions, first off, what form is this in? It's in general form, yes. And we know that this graph should open down because what's the value of A?
-1.
It's -1. It's written backwards though. Don't let the backwardness throw you off, okay? It's the same thing as saying negative x squared plus 4x plus 3. 3 represents what?
C.
The c, aka the what? And on the graph, it will represent what?
The y-intercept.
The y-intercept. So already you know what the value of a is. A is 0, 3. Now, granted, it didn't ask you for that, but, you know, it's good to know. We actually do need it, though, to do bi and double I. Find the coordinates of b. B represents the what again?
Vertex.
Vertex. How do I find the x coordinate of the vertex?
Negative B over 2A.
Negative b over 2a. What's b in this problem?
4.
So that's negative 4 over a. What's a?
1.
Careful.
Negative.
Negative.
Negative 1. Okay, so that's negative 4 all over a negative 2. What is that?
2.
2. So the x coordinate of b is a positive 2. And also, when you look at this graph, your x coordinate should be positive because it's on the right side of the y-axis. Okay? So that's another thing. Like, let's say if you did plug in 1 for your value of a, it wouldn't have made sense to the graph. Okay? How do I find the y coordinate? Plug it in. Now, please be careful. X is 2.
Mm-hmm.
X is being squared. And then is being negated. Okay? A is a negative 1. X is 2. And that's being squared. You see the difference? I'm not squaring negative 2. I'm squaring 2 and then making it negative. Okay? So be careful. Bless you. What's 2 squared? Times a negative 1. 2 times 4. Plus 3. What is that?
7.
So there are my coordinates of b. Questions up to this point? Make sense? Now it says another point C, which lies on the graph of y equals f of x, has the same y coordinate as a. If it has the same y coordinates of a, you have to plot and label C on the graph above. If it has the same y coordinate, where is C located on that graph?
0, 3. Or 3 at least, like for the Y.
3 at least for the y. And so it basically should be where? Then when I saw what you was doing in your paper,
Next to A.
next to A, but
Or is that the opposite side?
Opposite side.
on the opposite side. Because it has the same y coordinate as A, but it's still on the graph, so it needs to be on the other side, basically, of that axis of symmetry.
So now
So you just
4, 3.
don't you just do those two plus each other divided by 2?
Wait, if B is the axis of symmetry, if that's 2 over, then would you just add another
4,
2?
3.
That would be the easier way to do it. Because since you don't know what C is and it's asking you to find the x coordinate of C, since you know that this is at 2, they are equally spaced out. So then this has to be the same distance over.
Wait, how do you know that it's 2?
Because remember, the x coordinate of the vertex was 2. Mm-hmm.
The vertex is in the very middle.
Smack that in the middle. And again, that axis of symmetry cuts that parabola in half. So if you're at 0 for A, that distance is 2 units. So then C needs to be 2 units as well away from it as well. See how IB gets you just a little bit? IB problem. All right. Now, this you are going to be writing down. Not too much. You're not going to be writing too much by hand. You probably don't even need to write this. It's going to be a lot of desk stuff, okay? You may have to sketch a few graphs, and if you do, you use inductive reasoning, okay? If you're not given a function, okay, you use the information that you are given to draw the quadratic, okay? For example, it's asks you to sketch a graph of a parabola with a vertex at 1, 2, and a range of y is greater than or equal to 2, okay? A lot of this is going to be on your desk, so right now, get your marker. We're going to sketch this. So we're going to draw an XY plane. It says I have a vertex at 1, 2. Go ahead and put that point, 1, 2. Put that point, 1, 2. This is where it's located. X value is 1, your y coordinate is 2. Good stuff. Now it says the range is y is greater than or equal to 2. Now if this is a quadratic, that means it can either open up or down. Which one does this? Which one is it for this? Is it up or down? And you know that because it's all the values that are greater than 2. So then there you go. You have your sketch. Yes? Okay. Now with this particular one, they wouldn't ask you to write the equation based off of this information because all you know is your vertex. You need another point in order to actually write the equation. Okay? Yes, you could go to vertex form, plug that in, but you still need another point to find the value of A. Okay? On your desk, what I want you guys to do is I want you to sketch this particular graph. It has a parabola with a vertex of 1, -3, and x-intercepts at -1 and +3. I want you guys to sketch this out on your desk. Does this graph open up or down? It opens up. And you know that because with the vertex at 1, -3, and x-intercepts at -1 and +3, the curve has to go through all of that information. Okay? So you automatically know that A has to be what type of number? It has to be positive. It has to be greater than 0. Now from this, I can write my equation. Okay? The easiest way to probably write the equation for this would be using x-intercept form. Or factored form. I apologize. Factored form. Okay? Because you are giving your x-intercepts. Okay? However, you are giving your vertex as well, so vertex form is another option. It really is. Okay? So, if I were to take the general form for factored form, that's A, x minus P, x minus Q. What's the value of P? Either one, either -1 or +3. Okay? P has to be one of the x-intercepts, Q has to be the other one. Okay? So I'm going to plug that in. If I make P -1, x minus a -1 make a what?
Yeah, positive.
It's a positive. And then it'll be x for the other. Now, so far, I'm almost done. The last thing I need to do is find the value of A to get my function. This is where the vertex comes in. Another point on the graph. In order to find that value of A, I'm going to take that other point and plug in 1 for x and -3 for y. So, -3 for y and 1 for x will basically give me an equation where I can solve for A and then get my equation. Does everybody see that? What's 1 plus 1?
2.
And what's 1 minus 3?
-2.
What's -2 times +2?
-4.
So this becomes -3 equals a -4a,
You should just divide for both sides.
and a negative divided by negative is a. So a is a +3/4. So my function for this would be 3/4 x plus 1 x minus 3.
So P and Q are the x-intercepts.
Yes. P and Q in factored form are your x-intercepts. But P and Q in vertex form is your vertex. Does everybody see how that works? How you can write the equation from the graph? Okay?
From that, do we need to plug it in, like multiply, 3/4 over times x and then plus 1?
Now they ask you to write in a particular form.
Okay.
So let's say it asks you to write in general form. This is not general form, but it is one of the forms. You would FOIL this out and then distribute the 3/4 over to get general form.
We don't have factored or vertex in the
In the reference book? I don't think so.
so we have to remember it.
Yeah, so you gotta remember those forms. Get on your reference book.
But that equation you made is factored from.
This will be the factored form. So far, so good? All right. I want you to sketch this one. Now you'll be able to tell that your vertex is at -1, 2, which means it should be labeled, or you should have some type of a label on your grid, right? And it opens how? And it opens down, yes, and you know that because it said it was less than. Do I have enough information to write this equation? No, because I need one more point to do that. Okay, I need that additional point to find the value of A. Clear your desk, I want you guys to do this. And we have a parabola with an axis of symmetry at x equals 0, and a range at y is less than or equal to -1. I want you to sketch this. Does this parabola open up or down? Down. Where's the vertex? 0,
-1.
-1. And you knew that because you had an axis of symmetry at x equals 0, so that means it had to be on the y-axis. And if the range is less than or equal to a particular value, that means that that vertex had to be at -1. And it said less than, so it opened down. Okay? The range of any quadratic is dependent off of that y-coordinate of the vertex. Okay? Every time. Every time. Do I have enough to write the equation?
No.
Nope. Okay, let's go to this one. Graph this. Does this parabola open up or down? It opens down. It has x-intercepts at 3 and 0, and the range is less than 1, right? Now, where's that represents basically my y-coordinate, my vertex. Where's my x-coordinate? 0.
1/2.
It's what?
1/2.
1.5.
1.5.
Because remember, these are your x-intercepts. Your axis of symmetry is halfway between them. So halfway between 0 and 3 is 1.5. And because it has to open down with a range that's less than or equal to 1, your vertex is actually located at 1.51. Do I have enough information to write the function for this one? Yes. I have my x-intercept, so I can use factored form, and then I subsequently found my vertex, so I could use that as well. But we're going to not write the equation for this one, we're going to write the equation for the next one. All right? Do this one. Does this open up or down?
Down.
It does open down. You have a point at 0, -2, and you have a point at 4, -2. Now, these aren't x-intercepts, but they are equally spaced because it says that you have a maximum value at a +2. Maximum meant that it had to open down. Okay, that's how you get a maximum point. What's the x-coordinate of the vertex? 2, because it's the halfway point between 0, -2, and 4, -2. And because it has a maximum value at a +2, 2, 2 is your vertex. Do I have enough information to write my equation? I sure do. The easiest way to write this would be starting in what form? Vertex. These aren't x-intercepts, so we couldn't use factors. General, you gotta know a good amount of information to be able to, you can, but it'd be a lot more work. Vertex would be the easiest way. Vertex is y equals a x minus p squared plus q. In this form, p and q represent the what?
The vertex.
The vertex, the x and y of the vertex. So I have y equals a x minus, what's the x-coordinate of the vertex? 2 squared plus, what's q? 2.
So Q is always Y.
Q is always the y-coordinate of your vertex when it's in vertex form. Now to find A, I just need one more point. To be honest, either point will get me the solution. Which point you want to use?
The first one.
Can't use the vertex, I've already used it.
0, -2.
0, -2. So I'm going to plug in -2 for y and 0 for x to find the value of A. 0 minus 2 is a -2. What's -2 squared? 4. So I have 4a plus 2. How do I solve for a? Subtract 2. What's that?
Negative 4 equals 4a when you divide by 4.
And a equals?
Negative.
So my equation in vertex form is negative 1, which you don't have to put the negative 1, but I'm putting it. X minus 2 squared plus 2. Questions?
So what's the P again?
P and Q in vertex form are the X and Y coordinates of your vertex. Alright? Now, as you can see, when you are given a graph or directions on how to sketch a graph, how we can write the equation depending on what we're given. Okay? So for this one, we had the vertex, we had 2 points, we had enough information to write the function. Okay? This one back here, we didn't have enough. Okay? You need either a vertex, x-intercept to start it, and then you'll need another point of some kind. Okay? But once you've used, like in this case, once you've used the vertex in vertex form, you can't use that same point to find the value a. You need a whole nother different point. Okay? The last one I'm going to show you is that one that's on your form or on your paper. Here we have x-intercepts and we have a vertex. Okay? So we have enough information to write our equation, and we even got a y-intercept. We got a whole bunch of information. Okay? But we have enough to write the equation ourselves. Okay? We do. So in this case, I am going to use the fact that I have my vertex, which is at -2, -9, to go ahead and write this equation in vertex form. So again, this is vertex form. And so I'm going to plug in my x and y coordinates, which are my p and q, into my vertex form. So that's going to be x plus 2 squared minus 9. Remember, since it's an x minus p, a negative and a negative is going to make a positive, hence why you have that positive 2. Now I can use any one of these other 3 points. I can use one of my x-intercepts, or I can use my y-intercept here, which is at 0, -5, to plug in for x and y. So I'm going to use -5, and then 0, and then I'm going to solve for a. 0 plus 2 is 2. Square it is 4. So I have 4a minus 9. I'm going to add 9 to both sides to get a positive 4. Then divide both sides by 4, and a is equal to 1. So in vertex form, my equation is y equals 1, x plus 2 squared minus 9. Now, if the problem ever asks you to write it in general form, if it asks you to go in general form, what you want to do from vertex is you want to take care of the squared part and then subtract 9. And just remember that anytime you see a binomial square, that's the same thing as saying x plus 2 times x plus 2. So you FOIL that out, that'll give you x squared plus 2x plus 2x, which is 4x, plus 4 minus 9. And then, of course, you combine like terms. So in general form, your quadratic is x squared plus 4x minus 5. And that does hold true that our constant, our c, our y-intercept is -5, which it was. And that's how you use your properties to write equations of quadratics, sketch them, as well as using a general equation to pull out all that information.